Okay, here's the parametrics equation on question on this particular paper. We've got to start with dx by d theta and dy by d theta. So you just differentiate what you see and get 2 easy marks for differentiating these functions. Then we've got to find the gradient of the curve, which of course is dy by dx. So you have to remember what you do with these two things. Well, if you've forgotten, you should really check in your notes, but it's dy by d theta divided by dx by d theta, which gives you dy by dx. So you can either substitute theta equals pi by 6 into these two answers and then divide, or divide that answer by that answer, substitute pi by 6 in, and find the gradient of the curve. Should be in a nice exact form. Then in part B, we've got to show that the Cartesian equation of the curve can be written as this. Now, there are always some marks to be earned on a show that simply by verifying. So one approach would be to try and substitute in x and y in both cases. But it's always best, and sometimes the only way of getting full marks, is to simply start with one side and get to the other side. On this particular case, you could start with either side. There's nothing particularly wrong, in fact, in starting with what y squared is, because one thing you need to pick up at some point is you need to deal with sine of 2 theta. You know an identity for sine of 2 theta, so start with y squared equals whatever that identity tells you sine 2 theta equal is, square it out, and when you've squared all that out, you'll get something with a sine squared theta and a cos squared theta. And of course, cos squared theta, we want to have an x squared in the answer. Cos squared theta is just that x squared, so that's fine. Sine squared theta, however, you've got x is cos theta, you've got to express sine squared theta in terms of x, so you need to remember the identity that links sine squared theta with cos squared theta. So when this is all expanded out, you'll get a number there. You've got a cos squared theta that will just turn into x squared. You've got sine squared theta that will turn into something expressed in terms of x squared, because sine squared theta can be expressed in terms of cos squared theta. And when you've done that, you should have something that looks extremely like that, and you'll be able to spot what k is.